Hi there. This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're solving the 67th Project Euler problem. As always, I will link to both Project Euler and my repo in the description. Let's dive in. Problem 67 is maximum path sum 2. By starting at the top of the triangle below and moving to adjacent numbers on the row below, the maximum total from top to bottom is 23. I have the path here. Find the maximum total from top to bottom in triangle.txt, a 15K text file containing a triangle with 100 rows. Note, this is a much more difficult version of problem 18. It is not possible to try every route to solve this problem, as there are two dynamics altogether. If you could check 1 trillion routes every second, it would take over 20 billion years to check them all. There is an efficient algorithm to solve it. To have 20 billion years, right? Just kidding, probably nobody actually wants that. So, actually, before I switch to the code part, looking back at problem 18, this was the triangle then. I solved this back in 4 months ago, almost to the day. I pulled up the code for problem 18 here. So in problem 18, I had all of these, I had a list of lists, effectively. And what I did is I just kind of I set up a maximum total to be like the very first number, and then I had a previous index variable starting at 0, and then I effectively went through every row. And for each row, I also looked at the next row. And I calculated the sum for let's see. So I calculated the sum for including the next row, whether we did one index or the next index. So going back to our illustration here. So basically for the first row, I looked at the next 2 rows. I said, okay, so for either of these numbers, which is the higher sum of this and the next number below it? And then based on that, I set both the total and the previous index. Then I did the last row separately, and I just printed out that maximum total. So what I want to do is I want to see if the same algorithm will work for problem 67 with the file. I'm hoping that it does. So I've just copied and pasted all of this code. But instead of doing all of that, we need to read in the file. I'm also going to delete what is it? So how do I read a file? I'm gonna go ahead and open this file as well. Okay, so each line is a row, which is good for me. I think all of the previous problems where I had a file, it's just one line. Oh, not problem 54. So let's go to problem 54. See how we read in this file. Alright, this has a bunch of functions. Okay, so we probably want to do more like this. I'm just going to copy this whole thing over. Read in the line. So here, I'm just going to say row. Strip dot split, which returns a list of strings. Then we don't need to worry about these ands. But we do need to have it row stuff in here. Now we just run it, see if the exact same algorithm that we used before works again. So it did, but that number is very, very large. That seems too big. Oh, I know what we're doing. That's not a sum. That's a string. So we're just gonna do int. See if we get a different answer. Okay, that's a much more reasonable number. And it worked in a very, very short amount of time. Thus showing that well, if we'd gotten the correct answer, it would show that like the same algorithm continues to work quickly if okay. So what I'm thinking now is this algorithm didn't get the correct answer for this much larger triangle. And I think that we can make that happen by looking at the next 3 rows instead of the next 2. Uh, so be very careful here. Go ahead and second to the last row logic real quick because it uses exactly this logic. Should give us the correct answer for the last couple of rows. But we still need to finish building out this. Logic was gonna the code's gonna end up. Let's see. So next row. Now instead of looking at first and second sum, we're going to have first sum and first second first and second. So don't need to know specifically which one is the largest. We just need to know whether these two is larger than both of these two. If the first one is greater than both of the second ones, either if the first one is greater than both of the second ones, then we go with the first one. Greater than or equal to both of the second ones. Otherwise, we go with the second one. Now, let's see if that gives us a different answer. That should be all this algorithm. Okay, slightly different answer, which makes me happy. Let's see if they use the correct answer. It is not. Okay, so I have decided to try a completely different approach, not based on what I did in problem 18. So I'm going to be reading the rows in from the file, and then I have in it here the smaller example, and I'm actually going to be working with that first, just to make life a little easier. So a good thing. So if we go back, I'm going to edit this one to exclude some of the work I have already done on this problem. But to solve it, we need a better approach than trying to figure out the max of a subtriangle even. At least directly. So something to notice here is if you think about it from the top down, it gets very, very complicated. But if you think about it from the bottom up, 63 could either add to this or this, and obviously this is the larger number. So if you take for each number here, the larger of the two numbers it could branch to, and add those together, you end up with a new last row. And then if you keep doing that, you eventually end up in the very top row. So the challenge is to program that out. I'm going to go ahead and try it. So we need to look at the 2 rows at a time, and the row will constantly change. So let's do a sum row, which is that last row, and the second to the last row. So in this case, the last row is literally rows -1, and this is rows -2. And what we want to do is create a sum row. Um, yeah, so we're going to say while sum row dot size or let's just do a while true for now, and then at the very end of the true statement we'll say if sum row dot size or length of sum row rather is equal to 1. So I guess I could just say while not length of sum row is equal to 1 instead of while true. I was going to say then we break. And we no longer need this maximum total variable. We just print that. And it's underlined because Python is fussy about formatting. Okay, so basically we need to calculate there's probably a better way of doing this, but right now let me just get the code out so you can see what I'm thinking. So for num in last row, or for num in second last row, really. Actually, it's going to be for I in range length second last row. Sum row append the max of second last row I plus second plus last row I or second last row I plus last row I plus 1. So a little bit complicated. I probably want to pull this out into a larger thing. So basically, for every item in the second last row, we go through, we figure out what the maximum sum of that plus the row after. And then, when we get done with that, last row is equal to sum row, and second last row is equal to rows, and this will start at -3, but let's do this a little bit differently. So Let's make this a for I loop, because apparently those are my favorite. For I in range -2 to 0. I think that'll work. Feels like there's a better way of doing that that is less confusing. Yeah, that seems a little bit easier to handle. And then of course this becomes J. So second last row. I'm actually going to set at the beginning of the loop here. And this is going to be rows of I. I'm going to reset I to empty every time. Oh, I can't do it like right there, but okay, so this, I think, will work for this triangle. Let's see if we get the 1074 answer and how long it takes. Okay, not quite right. Um, yep, this has to be -1. Now we should get the correct answer. Yes. And I do like the idea of printing out the entirety of the sum row, just so that we can verify that we have reached the very last row. So I'm going to leave it like that. And now I'm going to comment this out, and I'm going to uncomment this code, which just reads through the file, and see what answer we get now. Okay, we got 7273. The largest number I've seen spit out previously was 7247, I think. So hopefully this is the correct answer. Let's find out together. Confirmation code was not valid. Okay. Okay, that is the correct answer. I'm just double checking. 7273 is what I got. Cool, cool. All right, so once you think about it from the bottom up, it actually becomes relatively trivial. And I'm going to call it there for this one. I'll catch you in the next.